Welcome everyone to another episode of Clearly Conveying. I am Jeff Poe, manager of the Field Engineering Group for PPI, and I am being joined today by Mr. Dallas Houchins, who is our field engineer for the Midwest. How are you doing today, Dallas?
Good. Glad to be here.
Awesome. Well, today we'd like to discuss AR lagging. So before we get to any technical details about the AR lagging, Dallas, can you tell me, when it comes to rubber lagging, in all of your experience out in the field, what's one of the major complaints about rubber lagging?
So I think one of the main thing is if a customer needs it or not, and they're thinking, well, the rubber's going to wear weird, right? We might get some weird tracking things that are going on once we see the wear in the rubber, but the reality is that the steel's going to wear the same way. The lagging's going to give you a little more life. So really that's what your lagging's for, is that wear life due to either carryback material on the dirty side of the belt or any other application issues that might cause wear in your pulley rim.
That's an excellent point, right? Because when we start thinking about conveyor pulleys, typically the fatigue life of a conveyor pulley is somewhere between 10 and 20 years. And so if your pulley can last 10 to 20 years, and your lagging might wear out every 2 to 3 years, if you can keep lagging on it longer, you're going to get longer life out of your pulley, right?
Right. And when we talk about our larger pulleys, when we can strip and re-lag those and not get into our rim thicknesses, and then we can get those pulleys to last that 20 years that you're talking about, rather than whatever the 2 to 5 years, that depending on how much wear they're getting.
And so the fewer times an end user would have to take a pulley out for relagging, the better, right?
Right. We're going to save costs from taking the pulley in and out, and then obviously using the same pulley again and again. You're not buying a new pulley. So
right. And not only do you prolong the life of the lagging of the pulley in a situation like that, but your belt will track better longer in a situation like that.
Right. Correct.
Okay. Awesome. Well, this brings us to this wonderful discussion about AR lagging. So today I'd like to just talk a little bit about the differences between SBR 60 durometer standard rubber lagging for conveyor pulleys and AR lagging. So Dallas, can you tell me, is AR a complete different material, or is it an SBR? What is AR?
So essentially what AR lagging, our AR is a proprietary blend that PPI uses. It uses SBR rubber in the lagging as well, but we add a mix to it that allows it to be more resistance to abrasion wear, which is sliding wear of something sliding over your material. That's going to reduce the amount of material that's there. So it's going to rip off a little bit of that, a little bit at a time. But what the chemicals that we mix in with the SBR allows it to resist that abrasion much more effectively than your standard SBR rubber.
Yeah. So with that thought in mind, some of the applications that I have seen out there that require a lagging to be abrasion resistant is like hard rock, granite, silicon sand.
Yep.
But what other type of applications do you think of might do well using AR lagging?
So the territories I'm most familiar with are, the North Midwest. That's what I cover. It's Minnesota, for instance. In the western part of Minnesota, they have like a pink gypsum, really abrasive. Like there's one plant I was at, a standard wing pulley, the contact bar was wearing through. Every year they were replacing this. So we had a different product for that. But as far as with your bend pulleys that are seeing the dirty side of the belt, AR would be a perfect spot for that. Sand applications, even grain, that fine dust, even though grain's fairly soft, not hard like rock or sand, having that dust that's so fine, it acts like sandpaper and wears off that rubber as well.
So essentially any application where an end user may be seeing accelerated wear compared to other conveyors in their system, they would want to consider AR, right?
I think if it's something that a customer's noticing, that the lagging isn't lasting as long as they expect it to, right away is AR lagging is going to be worth it to that customer.
Let's talk a little bit about some of the differences in the testing of AR lagging versus 60 durometer SBR. So there are primarily two types of tests available out there in the industry. And without the testing, I think it's important that we talk a little bit about it, because if you look, we have two samples here, right? And so here we have a sample of 60 SBR, and then we have a sample of the AR SBR blend.
I think the first thing you can notice is you can't really tell the
you
difference.
You can't tell the difference,
Yeah.
right? They look exactly the same.
That's usually one of the things customers say, well, how do I know
Right.
it's AR versus SBR? And really, you know, the performance is where you're going to see
Yeah,
that.
the performance and you know, the original specs. And I think too what PPI is working on a couple of different options there. You know, we have the green wear strip for regular 60 SBR, and that I believe there's going to be potentially a red wear strip embedded in the rubber for AR.
Yeah.
That way, if it wears down, you start to see red, you know it's AR lagging.
Perfect.
Yeah, something along those lines with the colors. But now, more importantly, is the testing. So, how do you know how well the AR is going to perform? And there's essentially two different types of tests. There's what we refer to as a G65 test, which just measures volumetric loss of two different materials, direct loss. And then there is the DIN testing that's also industry known throughout the industry. And it's a more standardized test that people use truthfully throughout the industry, throughout the world. So let's talk a little bit about both of those because they correlate. Both of those tests, they're two different tests. They both measure loss of material, but they correlate very well with regards to showing us how effective this AR blend is going to be.
Yeah.
So can you describe a little bit the G65 test?
Yeah, the way I like to think about it is imagine a spinning wheel that has some abrasive material, maybe sandpaper, just to visually see that. And then you put a sample of your rubber on a lever that just sits on that sandpaper, and we're just going to rotate that wheel for a set amount of time and see how much material is lost from our original sample. Really the difference between your G65 and your DIN test is on the G65 you're only measuring the loss of your sample material, where in the DIN test they have a material that they use that they compare all of their materials to.
So you have a reference material.
Correct.
And then you have a test material that you're going to look at the ratio between the two.
And essentially the ratio, if it's comes out with a higher number, that means that
it's more abrasion
resistance, and if it has a lower number, it means that you've lost more material and it's closer to your comparable material, and therefore you've had more material loss.
So if our customers or end users are out there and they're looking at the DIN chart, the higher abrasion resistant number means more abrasion resistance, the lower means less. And then more specifically with the G65, that's just measuring direct loss. I think that test is super telling because in our G65 test, for example, the SBR60 lost like 115 cubic millimeters of material in the test, and then the SBR blend, the AR resistant lagging, lost half of that, like 57. So if the AR resistant lagging loses half of the materials, that kind of give you a feel for you should.
So you basically correlate to either half the material loss go over the same given amount of time, or the way I think about it out in the field is roughly 2 times the life.
Two times the wear life.
Life, right? Now, the only thing that you got to think about is probably that's maybe you put a new system in with their standard SBR and you want to upgrade to the AR. Now that system's been running, you might have more buildup and stuff on the belt at that point, so you might not get that exactly apples to apples 2 times, but it's going to be in the ballpark, because obviously that testing is under a controlled environment. You throw in weather and different variables, it's going to change a little bit, but
the effectiveness of belt scrapers, how much carryback you're getting, all of those kind of things come into play.
But we can guarantee more life. We just obviously that's going to vary depending on the application.
So I think we've established quite well that customers can have confidence that they're going to get much longer wear life out of abrasion resistant lagging from PPI, correct?
Yep. I mean, we can, like you said, we can guarantee there's going to be more life. It's hard to nail down a number, but you can confidently, we can go to our customers and say, hey, you use the AR lagging, you're going to get better performance than this standard SBR. And you're only paying
up to double the life, right?
Right, and you're only paying maybe 30% more. So maybe doubling the life for a 30% up
premium.
That the numbers work out in the favor of
so that's less relags that you have to do over the life of the pulley, and to less times you have to pull that pulley out of service and all the labor costs associated with that and downtime. AR lagging sounds like an attractive option to me.
And that's what I think our end users look for. They look for cost saving effects for longer life on components, less maintenance costs, less in and out pulley costs, less freight costs. Those are all the things that our end users are using. So hopefully our customers and distributors can look into getting this product in front of them.
Dallas, thanks so much for joining us for this episode of Clearly Conveying, and we'll see you next time.